Okay, so for this week, we're going to cover counting and number sense for our math focus. And so we'll do that in a second. But I wanted to start off with a little video just talking about the importance of math and how math and language and literacy all go together. So please enjoy this little video first, and then we'll get into counting and number sense. Thank you.
I'm Jennifer McCrae, and I work here at Erickson Institute. I'm the director of our Early Mathematics Education Project. So I'm here to talk to you about math. Everyone's favorite subject, right? What we've figured out, we provide professional development to teachers. So that means teachers who are actively teaching preschool and kindergarten come to Erickson, and we have workshops with them where we talk about early mathematics, okay? And what we've figured out is that there are a lot of sort of misunderstandings out there about early math, what it is, what it looks like, and what it means to teach it. So I'm structuring my talk by pointing out some of these misunderstandings and trying to talk with you about why we think they are misunderstandings and get us all sort of on the same page. And so myth number one. For young children, learning mathematics is less important than developing early literacy and language skills. Now, some of us would probably say, yeah, maybe so. You know, I mean, if I had to pick one, I'd probably pick early literacy, right? You know, reading is so critical to any future learning, okay? So that makes sense. I understand why sometimes people think this is the case. And in fact, the evidence is clear that that's the way we kind of operate. This is based on some recent work done here at Erickson and with some other team members. And we found that if you went into 100 early childhood classrooms on any given day, you'd only see mathematics activity occurring in 21 of them, whereas there'd be 96 where you'd see language arts or literature. Art and music is somewhere around 30, okay? So clearly we're operating on this principle, right? Got to get that literacy in, which is great. Literacy is very important, okay? But we also have some interesting findings from a recent study. This was done at Northwestern University, published in 2007, and it's longitudinal data. What that means is that we were able to follow children. So we have scores when they're 5, we have scores when they're 8, and we have scores when they're 13. Okay? And we found that your early reading skills do in fact predict your later reading achievement. That makes sense, right? So how you're reading in kindergarten tells us how you're likely to be reading when you get older. Okay? We also found that that was true for math skills. Your early math skills do predict your later math achievement. Not a big surprise. But we also found that early math skills predict later reading achievement. And the same cannot be said for early reading scores, okay? For whatever reason, the early math scores have a much stronger predictive power. So where children are in mathematics at the kindergarten year predicts both math and reading at a later time. But the early literacy isn't providing the same kind of prediction, okay? It's not as related to what happens later. So, whenever we present this data, people say, well, why? What's that about? You know, help me understand it. Good question. In order to do that, I want to show you a game that we sometimes have our teachers do with the kids that they're teaching. We have them set up what we call a number station. And we say, make that number. And the number station that we're going to make today is based on the number 6. So I would have a table here, and it would have maybe a big card on it. It might have the numeral 6, and then maybe it would have 6 dots to help remind kids what 6 looks like, okay? And then I would put out a big bin of, these are called Unifix cubes. And we say to the teachers, put out only 2 colors. Okay, so you take out all the brown and the green and the yellow, and I'm just leaving the red and the blue, okay? you say to children, how many ways can you make 6? You give them a tray and let them go at it. So, of course, one way to make 6, if you have red and blue Unifix cubes, is 3 and 3, right? But you can also make 6 with 2 and 4, right? Okay, see these are 6. You can also make 6 with 1 and 5. So here's my 5 and my 1. And then there's 6 and 0. That's right. Okay, so there are a lot of different combinations, different ways for kids to make the 6. Okay? So this doesn't even have 0 in it as an example. And if you go up to 3 colors, right, you put some yellow in there, then suddenly, you exponentially increase the number of different possible combinations. Well, the point of the activity is to help kids begin to see the cardinality of number and the idea that numbers represent quantity. And one of the things that comes with that idea is this idea that a number can be, a 6 can be broken apart into 2 other numbers, okay? And that 2 numbers, 2 sets, can be combined to create a set of a different amount. It's an idea that is so basic that as adults, we take it for granted. I mean, it's an obvious, it's a no-brainer, right? But children have to learn it. They have to experience it. And so this is an activity that we would do to help them with that. And the reason I'm spending some time showing it to you is that I think it demonstrates how many different kinds of thinking are going on when children do this activity. They've got to be able to think flexibly. They have to be able to see that there are other possibilities besides the 3 and 3, okay? They've got to be analytical so that once they've created a couple of these, they can think to themselves, what's another way? They might do it, I did it systematically, didn't I? I started with 3 and 3, and then I went 2 and 4 and 1 and 5. A little kid might start by jumping around, right? All of one color, 3 and 3, 1 and 5, and then if they're trying to get to all of the different ways to make it, then they might have to get more analytical. They might have to get more systematic to see what are the remaining possibilities and to make sure that they actually do hit them all. There's a lot of abstraction in this and a lot of problem solving going on. Okay, so the kinds of thinking that go on when children are engaged in early mathematics activities apply much more broadly than do some of the skills that come up in literacy. They don't apply to mathematics in the same way. But math has built into it this emphasis on logical thought, on abstract thinking, on systematic thinking that has a lot of application when children are doing literacy. So that's how we explain that finding about early math scores predicting later reading scores. Reading scores.
All right, so I hope you got a lot out of that video and really start to understand how the foundations of math actually help with the foundations of reading and writing for later success for children. So just another little slide that kind of backs that up is this one that really talks about all these things that we've been talking about in class, integration of curriculum and open-ended or divergent questions, all of those types of things that we are doing in class that you're going to be doing with your children in the classroom. Not only are great for math and science thoughts and reasoning and processes and all those things, but are also great foundations for reading and writing and literacy, right? So activating prior knowledge, right? Going back to things that they've already done, making meaningful, posing open-ended or divergent questions, helps with vocabulary and communication, presenting new vocabulary, engaging in one-on-one or group discussion so they can have a back and forth and use that vocabulary. Scaffold child's language so that they have real simple vocabulary at first, and then as they get better and better at whatever task or skill they're doing, We expect them to use more complicated vocabulary, right? Facilitating problem solving. When they run into problems when they're reading or writing, they don't know what word, or they're having a hard time sounding things out, or figuring out what letter comes next. They can use these skills, these problem solving skills that they've had in math and science areas to help with the reading. Build phonemic awareness, right? Phonemic awareness is breaking down words into separate sounds, right? And so when we're talking about math and taking things apart and putting things back together, that's exactly what they're doing when they're reading, right? They're taking these parts, these letters that they know the sounds, and they're putting them together, right, to make a word. Or they have a word and they're not quite sure what the word is, and so they're breaking it up into these phonemes, which are the little the letter sounds, and trying to figure out what the whole thing is. That's math. That's addition and subtraction, right? And then, of course, as we have been talking about integrating literature, children's literature, into science and math. So books about rocks and books about water and books about, different things, counting, and which we're going to talk about today. And adding them, subtracting. All of these things that we have been talking about and that you're going to be doing for math and science actually help with reading and writing too. So know that doing math and science with children should not come secondary. It should be just as important as reading and writing with our young children. Okay, now we're going to move on to some math terms and some math ideas, and then we'll move on later on to our science exemplar activities. So a couple of things that you read about in the textbook this week. We're talking about counting and the number sense and number operations. So when we're talking about basic counting, there's actually two different kinds of counting. One, there's rote counting. Rote counting is when children recite the numerals in order from memory, right? They don't have to see them in front of them. They don't have to point to something. They don't have to count something. They can just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, it appears that they are counting and they know all their numbers and they've memorized the order of these things, but it doesn't necessarily mean that they know what the number 1 means or the number 9 means or the number 3 means. It just means that they have memorized how to put these words in order, but there may not be a lot of meaning behind them yet in that child's brain. On the other hand, rational counting involves rote counting, but taking it a step farther where the children actually understand what the meaning of the number is. They understand that number sense, right? It involves matching each numeral name in order to an object, right? So 1 penny means 1 penny, right? 2 pennies, 3 pennies. So they know exactly what the amount is. It's not just a random word that they're saying that they've memorized because they were asked to or told to. They actually understand the meaning behind it. So that's really important to understand, because although children may do rote counting very early on, oh, my 2-year-old can count to 10, my 2-year-old can count to 20, that doesn't mean they actually understand the number sense behind it. So that's a huge jump. Okay, so some basic principles of counting that teachers need to understand. Okay, so some basic principles of counting that teachers need to understand. One, because we need to understand where children are and what they can and can't do yet, what level they're at. So the first one is one-to-one principle. So a child who understands or is at the level of understanding one-to-one principle means that when they point to an item or a number of items, they understand that the word 1 means one thing, and it's 1, 2, 3, 4, 5. So they point to, they have 5 pennies, and they can count while pointing to each different one. 1, 2, 3, 4, 5. That child understands the one-to-one principle, right? A child who does not understand one-to-one principle or hasn't gotten there yet might point to 1 penny and go 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'll say that there's 9 pennies when actually there's only 1, 2, 3, because they don't understand yet the concept of one-to-one correspondence or one-to-one principle. Okay. The stable order principle, and again, these are all in your book as well. The stable order principle is the concept that no matter what you're counting, you're always going to start at 1, right? So if you have 1, 2, 3, you're going to start 1. When you have 4, you're going to start at 1, 2, 3, 4. If there's 10, you're going to start at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's stable. You always start counting at 1 and then go up from there. That's the stable order principle. The order irrelevance principle is that it doesn't matter if you count from right to left or left to right. It doesn't matter. You can count from left to right, 1, 2, 3, 4, or you can count the items from left, from right to left, 1, 2, 3, 4. It doesn't matter. You can go back and forth, right? The cardinality principle takes a little longer, and actually you're going to see a child here with all in just a second with these principles. The cardinality principle is when a child can understand that when they add one more, it's to a group, it's just the next number in line. They don't necessarily have to go back and count them all over again. And again, you'll see this in the last little video in a second. But they know that if you put one more, it's the next one in line. So if you have 5 little blocks out on the paper and the teacher puts one more and says how many, the child will go 6. They don't need to go back and start counting 1, 2, 3, 4, 5, 6 because they already have counted 1, 2, 3, 4, 5. They know one more is 6. So again, a little bit of a higher order understanding or concept of counting. Yeah, so those are the 4 basic principles of counting. So, in the next few seconds, I'm going to play all 3 of these videos one at a time, and they kind of show the different principles that we were just talking about, one-to-one, cardinality, and things like that. So these are obviously different children of different ages and therefore different levels of concept understanding. So enjoy them. This way you can actually see what I was talking about in the previous slide.
Can you tell me how many blocks you have?
1, 2, 3, 4, 5.
All right. How many blocks do you have?
5,
5. All right. Now, if I give you some more, how many do you have?
6,
You think you have 6 now? Are you sure?
7,
7. Now, if I put one more, how many do you have?
8, 9, 10,
Now, if I get tricky,
12,
can you tell me how many blocks there are?
1, 2, 3, 4,
All right. Now, how many are there?
1, 2,
How many are there altogether?
1, 2, 3, 4, 5, 6,
So how many blocks do you have on your paper?
6,
6 blocks. Now, how many?
1, 2, 3, 4, 5, 6, 7,
So how many?
7,
You have 7 blocks on your paper? If I give you one more, how many do you have?
1, 2, 3, 4, 5, 6, 7, 8.
How many blocks are on the mat?
1, 2, 3, 4.
Are you sure?
1, 2, 3, 1, 2, 3, 4.
You moved one of the blocks. You can move them if you want. Do you want to move them? It's So how many altogether?
1, 2, 3.
How many altogether?
1, 2, 3.
So there are how many blocks on your map?
3.
3 blocks, right. How many are there now if I put some more out?
1, 2, 3, 4, 5, 6.
Okay, so we're going to move on from counting, now that you've kind of watched the videos and understand the basic principles of counting, to take it just a little bit of a step further, which is number sense. And this first one really kind of talks about what the woman in the video was talking about, right? Number sense. So counting, a child can count rotely or rationally, but they may not truly understand what each number means, right? What it represents, right? A numeral like this numeral 6 is just a symbolic representation of something, right? That's why it's related to reading later on. So the child might be able to count things, but they might not know the deeper or higher level number sense, how to break down a number or a numeral, what it really means. So, and she kind of did this one in the video, right? So what does this activity demonstrate about numbers, right? So if you show children, like in the video, the numeral 6, and then you ask them to break it down and how to make, number 6 from blue blocks and red blocks, what are they getting out of it? What are they learning from something like that? Well, one, they are learning that numbers represent a quantity, right? This symbolic representation, this numeral 6 actually means a group of something, right? They're also learning from that activity that she was talking about that a number can be broken down and broken apart into other smaller numbers, right? 3 and 3, 4 and 2, 5 and 1, those things, right? And then to take it even a little step further, they're also being introduced to the concept that two numbers, two smaller sets, can be combined to make a bigger set, right? 3 and 3, so 3 blue and 3 red, can be combined to make a larger set, or number 6. So these are different concepts or experiences that they're getting that are really the basis for later higher math concepts. So, so what is number sense exactly? Number sense is the ability to understand the quantity of a set and the name associated with that quantity, right? So the name, the numeral, what it looks like that is associated with a group or a set of things. So the numeral 4 and the number 4 that you say out loud means 4 cars, a group of 4 cars. So that's what number sense means. That's taking counting to another level. Right? Why do we care? Right? Well, number sense is the basic building block for later mathematical computation, right? They have to understand what numbers mean, or what that symbolic representation of numbers means, to do math later on. You can't do adding and subtracting if you don't have number sense. You can't do algebra and geometry and trigonometry and calculus and all that if you don't understand number sense. So it's not one of those things that you can jump ahead and do. This is a really foundational understanding that they have to have before they move on, right? It is also something that develops over time. They can't get it when they're young. They're not ready to learn it because cognitively they're not ready to learn it. That's why younger children can count rotely but not rationally yet. Same type of thing. Children can count rotely and then rationally and then understand number sense. So it comes with their cognitive development as they grow. And it also comes from the ability or the experience to explore numbers, right? So unless we give them those experiences in early childhood, they won't understand number sense, and then they'll be behind in math. So math experiences and activities, although one of the ones that often gets kind of pushed off to the side, is really, really important because they need those foundational understandings for later math. So one little activity, and I'm going to show you some examples of children doing it here in a minute is that, of course, links reading and math, is the book 10 Black Dots by Donald Cruz, and reading that book, 10 Black Dots. It's a really cute little book. If you've seen it, I'm sure some of you have seen it before, but it lends itself not only to linking literature and math, but also to some really great one-on-one correspondence activities and number sense activities. So this is just a picture of an adult student doing it, but what children do is, after the book is read and you talk about the dots and you count the dots in the book, then children can use sticker dots and markers to design their own picture, right, just like in the book. And they can use as many dots and things if they want, and of course use then the markers to make more detail into the pictures. So here is an example of children doing that, right? So 5 black dots can make a cat. And so they put, I'm sorry, not 5, 2. I'm reading it. And that's my adult brain turning that thing around, right? So 2 black dots can make a cat. 3 black dots can make a smiley face, and it goes on to the 4 black dots, and then 4 other black dots can make some sort of lizard or something like that. Phonetic spelling. But anyway, it just shows that they can start doing that one-to-one correspondence and grouping and things of that nature. So here are some other little examples, right? I make a 4, a quattro. Mine is 2 ghosts with eyes because 2 and 2 is 4, right? So 4 black dots. I did my 4 in a straight line. It's like buttons for a snowman. So just some examples of how you can start using these mathematical activities to do some support for these new math concepts. Okay, so again, these are not things that you haven't already read in the chapters for this week, but the big ideas about number sense. Number 1 is numbers are used in many, many ways, some more mathematical than others, right? So some numbers can be used to label things, like time or area codes or zip codes or addresses and things like that. But also numbers can be used for mathematical equations and more complicated mathematical types of things. Right? And we kind of did these here in a second or before. So numbers can mean lots of different things, right? School gets out at 3:14, 314 people go to my school, those types of things. Those are different kind of types of concepts. One is cardinal, which we already talked about before. And cardinal is to indicate the amount, as in how many or how much, right? How many are in this group? If I count 1, 2, 3, 4, and I say how many are in this group, and then the answer is 4. 4 means how many are in that group. That's what cardinal means, which we were talking about before. The term nominal means to provide names for members of a set, as in jersey numbers or phone numbers. Those are nominal numbers or nominal number sense, right? Referential means to act as a shared reference point, as in let's meet at 5 on December 5th, right? It's a reference, so numbers can be used as a reference point. And then ordinal is numbers can be used to place things in order, right? To specify position in a sequence, like I'm first in line or second in line or third in line or fourth in line, those types of things. So those are the different types or vocabulary when we talk about number sense, how it can be used, right? In simplified forms, and then as it gets more complicated in mathematical equations later on. Right. The second big idea about number sense, and again, these are all in your book, quantity is an attribute of a set of objects, and we use numbers to name specific quantities. So we've already done sorting and attributes and things like that. So numbers put a actual specific quantity to that set, right, that have the same attributes. So what are the attributes of these apples, right? What do the apples have in common with the penguins? So we're talking about, oh, these 3 apples, that's an attribute of this set. And we have 3 apples, we also have 3 penguins, right? So again, it describes an attribute of this set that we're talking about. Big idea number 3 is that the quantity of a small collection can be intuitively perceived without counting. So this is something that, again, comes in stages as children's cognitive development progresses, in the ability to be able to see how many there are and count them without really counting them. You just see them and you know how many are in a group. Now a child can do small groups. You know, they can see 2 things and go, that's 2, without really counting them 1 to 1, or 3 or 4. As it gets to bigger numbers, then they have to start using their 1-to-1 correspondence and pointing to the items and counting them and things like that. All right, so that's the big idea number 3. And then kind of another kind of big idea, but we're not really counting as a big idea, is subsidizing. Subsidizing is the ability to see a small amount of objects and know how many there are instantly, right? So it's kind of that same idea, right? So researchers have demonstrated a strong relationship between the subsidizing skill and children's development of basic math skills, such as addition and subtraction. So if a child can look at a number, let's say, look at this dice here and go, oh, there are 2 sets of 3s, that is a good indication that they are very ready or very close to being ready to do addition, right? If they have to point to each little dot on the die and count them, then they're not quite ready yet. But if they can go, oh, there's 3 dots and 3 dots, and then go 1, 2, 3, 4, 5, 6, 6 dots altogether, then we know that they have the ability to break things down and see small quantities automatically.